MakerSnack. Choosing the right resistor size for an LED bulb. Far too many Maker projects suggest using a 220 ohm resistor with an LED bulb without providing any context. Now, while 220 ohm for an LED isn't a bad rule of thumb, we can do better. Now, if you followed along with our Pi Cabinet Light Up Med Reminder project, I mentioned in the build video that I describe how I calculated the resistor value needed for our LED bulb. So we'll do that here, and I'll also give you a first taste of Ohm's law. Now, we won't get into more complex calculations, say for multiple LEDs in a single pin, or considering series versus parallel resistor calculations, but hopefully this is a good place to start our learning. And the same principles used here should apply when calculating resistor values for other projects where a single LED is connected to a GPIO pin. Now, regarding the Pi Cabinet project, if you use the same red LED that I recommended in the parts list and a 100 ohm resistor, then you're good. But how did I know to use a 100 ohm resistor, and how can you calculate the right resistor if you're using a different LED? Well, let me show you. Now, without getting too deep into the weeds of electrical theory, we use a resistor on an LED component because if we supply too much electricity, the bulb might burn out or the LED might have a much shorter life. In fact, even if we use a resistor but the resistor is far smaller than we need, we can still have these problems. But if we use a resistor that's too big, well, we'll unnecessarily dim our LED, and if we use a resistor that's much too big, we might not see any light at all. So what we want is a resistor size that's just right, Goldilocks. So how do we figure this out? Well, we use Ohm's law. Now, this is a super simple calculation where three factors are in balance: voltage, current, and resistance. And the calculation that we're going to use is going to find the resistance, which is measured in ohms, which is voltage, measured in volts, over current, measured in amps. And sometimes in electronic projects like this, the components that we're looking at are measured in milliamps, which are 1,000ths of an amp. Now, how do we find these numbers? Well, the voltage is actually a calculation. What we need to do is we need to take a look at the supply voltage. And in our case, that's going to be the power that's coming from the Raspberry Pi. Now, we're eventually going to be wiring this LED up to what's called a GPIO pin. That's going to be pin 24 on our Raspberry Pi. And all of the GPIO pins on the Raspberry Pi provide 3.3 volts. But then what we need to do is we need to subtract the voltage drop when electricity flows through the LED. And we can actually find that number in the specs on the product page from where I ordered the product. Now, once we subtract these values and find the voltage, we need to divide this by the forward current of the LED, and we'll also find that on the product page. Now, this calculation is easy enough to make, but I'm going to be super lazy and use the calculator on the webpage ohmslawcalculator.com. And here are the values that we need to fill in: voltage and current, and this will give us our resistance. So now let's take a look at the page where I ordered my LEDs from. And we see right here, it says that this product has a 20 milliamp forward current. So let's return to the calculator, and for current, I'll put in 20 and then select milliamps instead of amps so that I don't have to divide by 1,000. Now remember, we said that the voltage was going to be a subtraction that starts with the voltage provided by the Raspberry Pi over the GPIO pins. And just to show you, the Raspberry Pi folks say on this page that that value is indeed 3.3 volts. But then we need to subtract the forward voltage drop as electricity passes through the LED. So back to our order page. And this value is a bit tougher to find, but it was given down in the Q&A section for this page. And now the numbers can vary according to LED color, but for the red LEDs, that number's between 2.0 and 2.2 volts. I'll be conservative and use 2.0, so our voltage value will be 3.3 minus 2.0, which gives us an Ohm's law voltage value of 1.3 volts. And now that we've got our voltage value and our current value, we can click on calculate, and we get a resistance value of 65 ohms. And just so you know about wattage in here, we want to make sure that the resistor that we're using is rated for a wattage value that's greater than the value that we see here. And if we look at the resistors that we're using, these are quarter watt resistors, which is pretty standard. A quarter watt resistor is 0.25 watts, which is much larger than 0.026. So we figured out we need a 65 ohm resistor, but a little snag: 65 ohms isn't a standard resistor size. Now, in this box of resistors that I've got, there's a 47 ohm resistor, which, believe it or not, is a standard size, and then the next one up is a 100 ohm resistor. Either would be fine, but a resistor that has a bit higher value is more conservative than one that's a bit lower, so I'm going to choose the 100 ohm resistor. Just make sure you're selecting 100 ohms and not 100k ohms. That's 100,000 ohms. That's a really easy mistake to make, and if you did that, your LED wouldn't light up at all. So hopefully this short video was useful in illustrating basic resistor size calculations for LEDs connected to GPIO pins. And if you stumbled across this video and you want to take a look at the Meds Reminder project that I referred to, check out this URL or visit any of the fun Maker and iOS projects on my YouTube channel. Good luck and make something awesome.